Welcome to the ACES Systems Dynamic Propeller Balance course. In this course, we will help you understand the basics of vibration, understand the benefits of balancing, and learn how to use the ProBalancer Sport to balance your propeller. First, let's look at the basics of vibration so we can better understand what is happening when we have a vibration problem. In this section, we will define vibration, explain why vibration occurs, explain how to measure vibration, and explain how to correct vibration problems. Let's begin by defining vibration as the unwanted, unproductive, cyclic oscillation of the propeller and engine assembly about its rotational axis. Remember, however, that there can be many sources of vibration in your aircraft beyond just an imbalance in your propeller. To identify the vibration source, a vibration survey should be conducted and manufacturer's limitations adhered to. Why does vibration occur? It occurs when the weight of a rotating propeller and engine assembly is not equally distributed. Vibration occurs when the dominant or heavy point attempts to continue moving in a straight line. The resulting force attempts to pull the assembly outside its rotational axis, and then the assembly orbits what would be the normal center of rotation, causing vibration. So let's talk now about how we can measure vibration using a vibration sensor, phototach, and analyzer. The vibration sensor generates a small voltage when mass compresses the piezoelectric element. Your ProBalancer Sport kit includes an accelerometer that measures the rate of change of velocity with time. This measurement is made in G's, or equivalent gravities, and measures acceleration. The analyzer mathematically converts this to inches per second, or IPS. We use this type of sensor because it is more sensitive to higher frequencies. The measurement is directly related to the force caused by an imbalance. We also need to measure the rotation of your propeller using the phototach included in your kit to emit a beam that is reflected from a piece of reflective tape installed on the back of your propeller. When the beam returns to the phototach, it sends a signal to the analyzer indicating that a revolution has occurred. When the analyzer receives the vibration data from the sensor and the revolution data from the phototach, it computes the size of the vibration, or you could understand it as the severity of the vibration, and the location of the heavy spot. It uses all of this information to generate a suggested solution for you to install on your propeller assembly to balance your propeller. There are multiple ways we could try to manage vibration problems in aircraft. For example, we could improve manufacturing methods, remove or replace defective components, perform a static propeller balance, or we could perform a dynamic balance that measures vibration while the engine is running. There are also multiple benefits to balancing your propeller. In this section, we will point out the negative effects of vibration and explain the various benefits of balancing your propeller. First, let's discuss the negative effects of vibration. When your aircraft is experiencing higher than normal vibration, you may experience cracked exhaust stacks and sheet metal, higher than normal occurrences of engine and prop oil leaks, higher than normal occurrences of light bulb failures. You will experience physical movements of the airframe, noticeable as a buzz in the seat, vibration in the yoke, and vibration in the rudder pedals. You can also experience malfunctioning or failed avionics. And your passengers may complain of uncomfortable noise levels in the cabin. Eliminating all of these problems is desirable, but now we'll look at some additional benefits of balancing. After balancing your prop, you may notice an improvement in fuel efficiency and flight performance. It extends the service life of the airframe and components, and it improves the comfort of the ride. In this final section of the Dynamic Propeller Balance course, we will discuss the step-by-step instructions for how to balance your propeller. We will cover when to balance your prop, provide you with an overview of the balancing process, go over the equipment needed to complete the job, explain how to set up the equipment, describe the data collection process, and explain how you can make adjustments to achieve a smoother prop. You'll know it's time to balance your prop when you're bothered by the vibration in the cockpit. However, some pilots have told us that they get used to the high vibration levels and only notice the difference after having their prop balanced. You may also notice cracks in your airframe and components. Depending on your propeller manufacturer and type, a propeller balance regime may be recommended at periodic intervals. An example of this is the Macaulay constant speed and turbine propellers. In this case, the manufacturer issued a service letter in 2001 recommending dynamic propeller balancing be completed when vibration levels are greater than 0.8 IPS. While anything between 0.15 and 0.2 IPS is considered to be acceptable by most manufacturers, Macaulay writes in the service letter that 0.07 IPS or lower should be your goal. To conduct a propeller balance using the ProBalancer Sport Analyzer, you'll need the analyzer, a phototach to measure phase angle and speed, a vibration sensor, balance weights, and hand tools. You should consult the FAA-approved references to guide you through the balance job, including your airframe, engine, and propeller manuals, and the ACES Guide to Propeller Balancing. If you do not have these references, the FAA stipulates that you can use the ACES Guide to Propeller Balancing. According to Aircraft Circular 20-37E, this procedure is not considered to be a major propeller repair unless the propeller static balance weights are altered or when your engine has more than 500 horsepower. To conduct the propeller balance job, start by inspecting your propeller assembly. You're looking for cracks, defects, damage, or anything else that doesn't look normal. Make sure you have freshly charged or new AA batteries in your analyzer before you begin. Next, we will attach the vibration sensor to the engine. Attach the vibration sensor perpendicular to the rotating shaft of your propeller. Consult your manual for suggestions or requirements. Remember to always attach the vibration sensor as near as possible to the forwardmost point of the engine and as close to in line with the engine bearings as possible. The base of the sensor should always point to the center of the prop shaft. Now attach the phototach and reflective tape. You may use tape to position the phototach on the cowling between 12 and 18 inches from the surface of the target blade and not perpendicular to the surface of the blade. We have found that a 5-degree offset works best. Install a 2-inch long and not less than 1-inch wide piece of reflective tape. Position this tape approximately 14 inches from the center of the prop shaft. Now attach your cables, making sure to route them away from rotating and high-temperature components. You can secure these cables using wire ties or tape to prevent movement and possible damage. Remember, these cables can be damaged when you close doors or windows on them, and make sure the cables are securely connected at the analyzer. Be careful when making these connections to seat them correctly before you tighten them. Once all your connections are made, you will start your engine and acquire data using the ProBalancer Sport. After the analyzer has sufficient data, you will be presented with vibration data reading and analysis of good, fair, rough, very rough, or dangerous. Now you will be prompted to shut down your engine. And you will install your first solution in the location suggested by the analyzer. Use the included propeller protractor to locate the weight placement locations. Test weights can be placed under the spinner retention screws. However, it may be necessary to use longer screws to do so. Therefore, you may need to account for the delta between the longer and the normal screw. After placing the test weights, you will now repeat the data acquisition by starting the engine and following the analyzer's prompts. Review the data and decide whether to retake or accept it. The ProBalancer Sport will now ask you to remove all the weights and provide you with the location and weight for the permanent solution. If you're unable to install weight at the suggested location, you can ask the analyzer to split the weights, and it will calculate 2 locations and divide the solution appropriately. Permanent weights are installed under the flange or on the bulkhead. You may need to use the included permanent weight calculator card to adjust the weight appropriately, since you may be placing permanent weights at a different radius than the test weights. Congratulations! You've completed your first dynamic propeller balance job, and now you're ready to enjoy some smooth flying. We strive to provide you with all the information resources you need to complete dynamic propeller balance jobs.